Whoa! We got a ton of you in the auditorium today, and I know that when I was walking through the cafeteria before, I saw flyers up for today's lecture. So I don't know who it was. Jose, eyes on you. But I know you're all crammed in here today because we are going over tips, tricks, and tabs for the PE exam for your ACI 318-14 manual. And yes, this is the one that is going to be on the upcoming spring 2021 PE exam. I know there's the newer one out, but this is the one that will be on there. So you're going to want to bring this one because all of the questions are based on this code. And from my own mistakes, when I took the PE exam a couple years ago, I was actually studying with the prior ACI manual, and it was actually just bumped up for my exam to this manual. So last second, I had to transition to this new code. You might be thinking, well, why is that a big deal? Most of the codes are really basically unchanged for the most part. There's some small things here and there. Well, ACI likes to be an asshole and reconfigure their entire code. Like everything was different from the previous code to this code, so I can only imagine going from this code to the new code. So this is a big one. This is the one. Now, as you'll notice right off the bat, there are so many beautiful tabs, color-coded, the whole shebang. But I tabbed this manual up when I took the PE exam. It had significantly less tabs than this. And then a coworker of mine took the SE exam. Oh yeah, the big boy. They passed. And they tabbed it up as well. So they added to the tabs I had and created this beautiful work of art. So we really won't be tackling all of these, just the ones for the PE exam that you most likely will be most beneficial to you. And just a reminder before we start that these tabs are all based on what I thought was most beneficial for myself when I was taking the exam. You could have differing opinions. You could have different sections that you like to tab yourself. So always make sure that you go through each one of these tabs that I'm listing off to you and make sure they jive with your studying and your test-taking abilities. It doesn't need to be a cookie cutter, one for one, that you do everything that I did, okay? Be confident with your studying. You got it. Let's jump in. Voila, boom, bada, prat. Here we are, ACI 318-14. Now, some of the pages might get cut off slightly from the extents of my camera, but I will be telling you page numbers. I'll be showing you the tab and what I called that tab. And again, I won't be going over every single one of these bad boys, but I will be going through the ones that I think are important for the PE exam. And I won't be going too far into depth about what each one is, just about how to locate it. And then you need to take a step further as a class and read those sections and understand them yourselves. All right? Gucci. First one, really easy. TOC, Table of Contents, page 6, broken down into basically how this ACI manual works is they broke it down into concrete elements. So one-way slabs, two-way slabs, beams, columns, walls, diaphragms, foundation, yada, yada, yada. Here we go. So that's how they broke it down in this manual, at least for a starting point, as you'll see. Next. Page 15, nomenclature. Again, this is a nice one to come back to in case you're in a rut with any of your equations in this entire code and you don't know what one of the abbreviations are, one of the notations are. You flip back here and it has all of them in alphabetical order of the symbol, okay, or of the nomenclature. Boom. Page 65, we have KL over R, and this is for kind of your column design. What I've actually made is a sticky note for myself, and if I slide here, maybe you guys can pause the video if you'd like, zoom in, but I wrote down for myself, fixed base is pitchfork, sorry, or Zeus's trident, you know, whatever you want to float your boat with. 1.0, pinned base is pitchfork of 10.0. That was just a quick little thing for myself. I gave the equation here for pitchfork sub A. I did call out that your I for your column and for your beam, you need to check cracking on page 72. So remember those. And then I said L sub U is floor to ceiling for column. Those are little notes I made internally for myself. Additionally, I did say for this L sub C is centerline to centerline of beams / floor, or top of floor to top of floor. Non-sway frames, I wrote braced. Sway frames, I wrote unbraced. Correct me if I'm wrong with any of that, but those were the little notes for myself that ticked my brain on for this section. Again, page 65. Next, be effective for T-beams. Well, look at where we are. We did a similar example of a concrete T-beam previously in this class, and if you don't know, well, now you know, and here we are. So this is page 68, and here's your table right here for your limits for effective overhanging flange width for T-beams. Boom. Next, we have approximate, moment, and shear. These guys, this is page 70, your table right here. So table 6.5.2. This is pretty handy dandy. I starred right here and said negative, so for your negative bending moment, brought it down to the footnote to say, to calculate negative moment, L sub n shall be the average of the adjacent clear span lengths. So that was a note that I made myself, just highlighted it in the book itself with an erasable marker or pen or pencil or whatever. If you have a company copy of a code, don't go scribbling all over it, okay? It's good to have some notes in there as long as they can be erased. If you have your own personal one, hell yeah, go ahead and draw all over that. Draw a big you know what in there. Next, on page 73, we have ICR, so that's your cracked moment of inertia. Here's your table right here on page 72 for your different members and conditions, so columns, walls, uncracked, cracked, beam, flat plates, flat slabs, all that good stuff. You're going to want to be here for that. That's a really handy one for the PE. All of these are so far. Next, page 85, we get into what I call H-min for one-way slabs. So this is your slab, one-way slab chapter, and right here you are given a table that allows you a minimum thickness of your one-way slab based on your supported conditions. So very important there. Next, reinforcing for one-way slabs, page 86, 87, non-pre-stressed one-way slabs. Here's your table right here for AS-min based on a couple criteria. Read that through. Next, page 95, you have H-min for two-way slab now. So a two-way slab, previous was one-way, now we're two-way slab. This is a new chapter here. And right here, you have a table right here, and you have right here as well. So two different tables here for that. Make sure you check in. Again, these are design limits, and just about all concrete elements have design limits from the start, so got to check those out. Next, page 97, you have two-way strip width, so how to analyze that per the code. You can flip over to the next page, page 98. You have some figures that talk about that, a little more in depth about it, so that's a good section as well. Moving on, you have reinforcement of two-way slabs. This is page 105, and actually it's on page 104, so it's this guy up in here. And always make note, so non-pre-stressed two-way, that means it's not, like it says, it's not pre-stressed. It's regular reinforced concrete elements. That's how they define it in this code. You'll see a pattern here. I did, minimum H and then reinforcing for one-way slab, then minimum H, then reinforcing for a two-way slab. So pretty straightforward, and I know that the chapters kind of break it up that way as it is, but the tabs just made it that much quicker. And that's what we want. We want to get that time. Time is money. Next, we flip over to one of those more kind of technical ones, I would say, and that is direct design method. So here we are. I actually wrote, these are my original notes based on practice problems I did for the PE exam. And in order to do a direct design method per section 8.10 on page 118, there are parameters and guidelines that you must meet for your structure in order to do the direct design method. So I wrote those out here. Again, pause here, zoom in, check it out, and then there is if I slide this up, you have limitations of use of direct design method. You have more limitations here, which I starred all of these as well. So this little chunk here as well, get on that. Again, page 118, 119. Now we're in another new chapter. This is the beams chapter, and I have another tab on page 131, and this is H-min for beams. Lo and behold, oh my gosh, it's like a broken record here. That's down here. There's your table, H-min. And what do you mean by H-min? Well, I mean when you start and you have a tunnel that you're building, and that tunnel needs to be 20 feet wide, and it's going to be a one-way slab supported by concrete beams. Well, those concrete beams have to span 20 feet. So right out of the gate, you can't just say, oh, well, I want to make a 4-inch deep beam, period. That's what I want, and I'll just size my steel as high as the steel size needs to be in order to make that work. Well, theoretically, maybe you might be able to make that work. I mean, you're not going to make it work, but you know what I mean. The equations might make a scenario work, but it's not all just about equations. It's about following the code and what the code dictates. So you have a minimum depth obligation. You might be able to make something work for a beam that's 12 inches deep, but if you have a 20-foot span, what you would do is, and say the beam is simply supported on each side, so your support condition is simply supported, you need to take your length of 20 feet and divide that by 16. So 20 over 16 gets you, I don't know, 1.2, I don't know, 1.4. That is in feet, so the units you did it in, so 20 feet, it's going to spit out feet, is your minimum depth of your member that you need, just per the code, not even talking about reinforcement yet. That is actually something for early engineers when your principals or your project manager reviews your concrete work. That's one quick thing right out of the gate that they check. They make sure, hey, you have a 20-foot span, we should be seeing at least the depth of a member of X, without even running through any calculations any further than that. So this is important for all cases across all concrete elements. Side tangent, but we're moving on. Next, we have, lo and behold, we had H-min for beams. Now we have reinforcing for beams. This is on page 136. And you have reinforcing limits that start right here. You start to have your AS-min criteria right here. This goes into more. I underlined 9.6.1.3 as there is an exception in order when you don't have to meet your minimum steel requirement in your member. And this keeps going on. So there's more here. So you have next page on 138. Bring it on over. You have cases where AV-min, so now you're talking about your shear reinforcement, is not required if you have a certain criteria, and then you have conditions. So this is an important table as well. Then you have your required AV-min table right here if you don't meet those requirements, where you then need to size shear reinforcement in your concrete beam. This guy right here. All right, moving on. Going to speed it up here a little bit. Now we have column reinforcing on page 157. It's exactly what you think. Next, we have walls. So concrete walls, you have H-min for walls. Here you can see this little diagram here is really helpful. And then right below it here is really good information. Here is at the actual table for H-min for thickness. So here, based on your wall type criteria, check that out. Again, page 165. For me, over here, I'm going to stop quickly because this is something just for my brain that I liked for my own sanity. So when we're talking about spacing S of longitudinal bars in precast walls, longitudinal in a wall meant vertical reinforcing for me. And then spacing of transverse reinforcement in a wall meant horizontal reinforcement for me. And then H was equal to the wall thickness. For me, it just totally messed me up in my head when your element was like a vertical element. So I wrote these little triggers for my brain on page 170 for that type of criteria talking about reinforcement. That's just me, but hey, if you don't want to, laugh at me in the comments. I'm all about that. Then you get into concrete diaphragms. This one I don't think is as important
like the video.
for the PE.
Do whatever you want.
Page 181.
Give it a like. Give it a subscribe. I don't know if you're feeling crazy.
Jump on
Okay.
over to foundation design. This is important for the PE. This is page 192. And I actually starred 13.3.2.1. And it says the design and detailing of one-way shallow foundations, including strip footings, underlined including strip footings, combined footings, and grade beams shall be in accordance with this section and the applicable provisions of Chapter 7 and Chapter 9. So that is kind of the vehicle in the code that sends you elsewhere to design your strip footings. Important. Next, we're jumping ahead. This is another big one for the PE exam. Page 315, I tabbed it E sub C / F sub R. So here's all your concrete design properties. All the way down, you have your modulus of elasticity, E sub C. This is your biggest one here that you'll need for the PE exam. Here's your two equations. God dang it. Here's your two equations right here based on your WC, which is your weight of your concrete. So you have that here for basically lightweight concretes, and then you have normal weight concrete is just this equation here. Very good to know. You have limits of F prime C up here, which is your compressive strength of your concrete. They give guidelines and minimums here in this book as well, so you can't just use 500 psi for F prime C just because you want to in the design of a building. It's just that's not code compliant. Clear cover requirements for on page 335, very important. Phi factor for all of your concrete elements that you're designing. So strength reduction factor, phi, because again, concrete design is all LRFD. Get that ASD out of here. And your phi changes based on the element that you are designing. So it's all packed right into this table here. Really nice. And I actually made a little note down here. So E sub Ty is based on, and it's not E, it's, I don't know, I'm going to call it eta. I'm so bad with Greek, sorry about that. Is equal to this equation right here. F sub Y divided by E sub S. So boom, I made note of that because that's important. So now page 349, values of, I'm going to call it beta 1. I know, you guys can just string me up in the comments. I'm sorry. I'm so sorry. But here's everything for beta 1 based on your F prime C of your concrete that you're using right here. And this is going to be used when you're designing and calculating your phi for your beam reinforcement design. And it depends on if your member is tension controlled or not, and it gets all into that. Next, on page 352, you have what I've tabbed as one-way shear. That gets into all of your shear, again, for one way, and the equations involved with it, different criteria based on what you have going here. I start on page 354. This is kind of your bread and butter equation. So for non-pre-stressed members without axial force, VC shall be calculated as that. That's kind of the most typical, but there's plenty of other options there. So read deep into this section, but definitely have it tabbed for the PE. Then we move on forward, we boogie on forward. If we just did one-way shear, you know we got two-way shear. Page 364, here's your table down here, right there. Your different options gives you a list of A, B, and C, so whatever your smallest value ends up being, you need to use that. And then it gives you kind of some figures to talk through some of the code requirements to kind of help your little noodle out there. Next, I know it's brutal. Page 374, we have torsion, so torsion tab, and it's all up in here. And I wrote in a little sticky note here, A naught is equal to 0.85 A sub naught H. And then theta equals 45 degrees for non-PT. And then cotangent equals 1 over tangent, which equals 1 when theta equals 45 degrees. So to me, this might seem stupid, but it was just another little note for myself that made me more confident. So I want to express everything that I did to you guys. Don't mind my disgusting fingers. I was doing work yesterday outside. I shower too, by the way. That's stuck on there. More talking about torsion and how that works and actually how the equations work. Right here, I've starred on page 377. And then right here is actually the little sticky note that I had. So an equation, blah, 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 it shall be permitted to take a sub naught equal to 0.85 a sub naught h. Oh, what are those? They tell you what they are in here. Actually, right here. Here's your little figure. A sub naught h equals your shaded area for your different cases. So check it out. It's important. You're going to need to know it. At least somewhat know it. These structural people out there, you will need to know it. Next, we move on and we have bearing. So concrete and bearing. This beautiful little table up here, this is page 379. You're going to need to know this. Talks more about bearing, especially this. So this is where you have like plinths or little concrete pedestals that then pick up like a steel column, that then those pedestals then sit on top of a concrete spread footing or something like that. So this is what's happening here in the design of those. And it talks about load distribution and stress distribution based on the geometries of your, your little footings or plinths or whatever you have. Next, you have deflection criteria right here. So check it out. Pause it if you'd like quickly, because I have a couple of little guys here that I wrote in. Basically, I said when you're trying to find a deflection, I said check out AISC Steel Manual, Table 3-23 for deflection equations for immediate deflection. But you have other, with concrete, but you have other things to consider with concrete elements with deflection. Nominal loads for deflection, I gross is equal to BH cubed over 12 for rectangular sections, obviously, so that's just based on the geometry. And then it talks about, I start up here talking about cracked sections, so check that out as well. That's on page 400 if I didn't mention that. Next, we're getting towards the end here, gang. Page 406, 407, we have minimum ratios for deformed shrinkage and temperature reinforcement for gross concrete area. So my tab was T and S reinforcing, so temperature and shrinkage, and those are your requirements right there, pretty straightforward. Next, you have development lengths, so LD and LDH, so for hooks, for just typical development lengths and all of the different equations and then tables and factors that go into it. I actually did a whole other video on this criteria as well, so check that out, throw another thumbnail up, but this is where it's located, page 416, 417, gets you right into the heart of it. Page 429, 428, you get into splices. So splices is another one. I don't know if specifically you need to tab this, but hey, if you'd like to, there it is. Then you get into transverse reinforcement on page 435. They give you some figures here. Starts right here on R25.7. Again, page 434 is where it actually starts. And lastly, on page 507, if you didn't have your little CRSI, Concrete Reinforcing Steel Institute student detailing cheat sheet printed out and stapled into one of your books, well, don't fear. As long as you have the ACI, that same information is provided to you in the back here. So page 507, I never knew that until after I took the PE exam, actually. So this tab was put in here by my coworker, so props. That's good to know. Whew. Okay, we made it. So that is the ACI 318-14 Steel Manual for all of you cats out there taking the PE exam come this spring 2021. Again, just to make sure, check the NCES website and assure yourself that this is definitely the code they're using. It is this year, but just get in the habit of checking that. Check all the other codes just to make sure you're on top of your crap. And Jose, thanks for bringing everybody in here today because we're jam-packed. Thanks to those flyers, which I'm pretty sure it was you. And grab yourself a second CRSI sheet if you'd like. Fine. I'll give it to somebody else. This is Rich with Kestävä. Until next time, good luck with your studies. I'll see everybody later. Peace.